Although sometimes the collision or separation of a few objects is the main point of a problem, other times there is a situation before or after the collision where energy is going to have to be used. So this video just looks at some of the situations, some of the more common problems that we may encounter that use both energy and momentum, and helps us figure out when to use which strategy. A lot of the clues in terms of what strategy to use can really come by just looking at the basic setup. So at the top of the screen here, this is the general way that we would be setting up some sort of a problem-solving situation that uses linear momentum. Notice that there are two masses before and after the collision, and that they each have their own individual speeds, or maybe they connect together or something like that. But the key thing is that there are two different objects and they are interacting. Where if you look at the conservation of energy, in most cases here we have just a single mass, and that mass stays the same before and after the interaction or the event. And so in most cases, if you're trying to figure out which method to use, look to see if there is one object or if there are two objects. Now, there are certainly exceptions to these rules, but for the most part, that's going to be a great clue to look for. You also want to notice that with energy conservation, there is going to be some sort of change in position. So either there's a spring involved, and so the position of that spring changes, that's a clear sign that energy is going to be useful, or the object changes its vertical position, its height. Okay, so those are again some things to look for that point to energy as the useful strategy. This is a classic situation here, something called a ballistic pendulum, where both momentum and energy is going to be conserved. There's a situation where some sort of object, maybe a bullet from a gun, is shot or launched and caught by a second object. And so right away, the fact that there's a bullet and there's a block and they are interacting with each other tells us that we would begin this problem, or at least use momentum to look at this part of the motion. And then when we look afterwards, this block is attached to a string, and that string swings up, and so there's a change in height. The objects move together. The bullet is embedded in the block, and so that there's really just one object at that point. So for this part of the motion, we would be thinking about energy. Here's another situation where we have two boxes moving along a tabletop. Maybe they're both sliding to start with, maybe only box 1 is slamming into box 2, whatever. The key thing is that at the beginning of the motion, there is a collision, two objects, so we would be using momentum in this situation. Whereas afterwards, maybe we would be asked, the box maybe sticks together or something like that, and we're asked to find maybe how far the combined objects travel when they get off the table. And maybe we'd use projectile motion or energy ideas, speeds, whatever, something like that. So this part of the motion is going to be using energy or maybe kinematics. But definitely not momentum ideas, because at this point the boxes would be two, or the two would be combined into one object, or maybe we're just looking at what box 2 does. But either way, it would be a situation where only one object is being studied. Therefore, it's not a collision or interaction, it's a change in position that often leads to energy ideas. Here's another situation where there is, looks like there's a block that's sliding into another block, and then there is a section here along the floor where it is rough, where there's a change to that surface. And so maybe there's some friction, there's work maybe being done by friction. So again, we would be using momentum ideas for the collision part, but we would be using maybe some work ideas or some energy ideas to involve the friction. So you can see there's quite a few situations where a collision begins the problem, and so momentum sort of controls or is the strategy that we're going to be using there, but that's not always the case. Here's a situation where maybe block M1 is pushed against a spring, and then it is released, and it later collides into block M2. So here would be a case where we would begin with energy conservation. Okay, again, why I'm thinking that is there's only one mass that's involved, and there's a spring involved. A spring is usually going to have something to do with energy rather than momentum. After M1 is released from the spring and it collides with M2, okay, there's an interaction. There's two objects. And so that collision tells me that momentum is going to be the strategy of choice.